Hello students, welcome to ECLIMU Learning Simplified and welcome to this lesson. In the previous lessons, we have discussed the different categories of forces. Now in this lesson, we are going to discuss adhesive and cohesive force as another category of forces. And in this case, we are going to look at the forces that sometimes you discuss in chemistry called intermolecular forces. Now, from your chemistry, you are told a matter is made up of small particles called molecules. And these molecules are held together by a force which you called intermolecular forces. Now, in this case, we are going to call them adhesive and cohesive forces. Now, what is the difference between adhesive and cohesive forces? That's what we are going to discuss. My name is Albert. I hope you are enjoying the lesson. So by the end of this lesson, I expect you to be able to define adhesive force and then give few scenarios where adhesive force is experienced. Also, define cohesive force and give few applications of cohesive force. And then finally, state the effect and explain the effects of cohesive and adhesive force. Now, what is adhesive force? Adhesive force is a force of attraction between molecules of different kind. Force of attraction between molecules of different kind. Now, in this case, it means different substances have different kind of molecules. For example, water and glass. Water has molecules which are alike, and then glass also has molecules which are alike, but the molecules of water are different from the molecules of water. So in this case, if you have a glass surface, you have glass, and then you drop a drop of water here, the molecules of water will be attracted to the molecules of glass like this. So in this case, the force of attraction between the molecules of water up here to the molecules of glass, that is what we call adhesive force. Adhesive force. When two types or two kinds of molecules, like molecules of water which look alike, then molecules of glass which also look alike but different from that of water, when there is a force of attraction between two molecules of different kinds, that is what we call adhesive force. Now we have different situations in which adhesive force act, and the first one is liquids wetting glass. For example, if you have a liquid like water and a glass, then it means you have two types or two different types of molecules. You have glass molecules, and then if you have your water here, you also have water molecules. Now, a force of attraction between water molecules and the glass molecules will take place, where the glass molecules will attract the liquid or the water molecules. In this case, since water can flow, and then after some time, the water molecules will spread. The water molecules, these are water molecules, and then this is glass molecules. Glass molecules. Now, since there is a force of attraction which we call adhesive force now, adhesive force of attraction between molecules of different kind, after some time, the molecules of water will be attracted throughout the glass, and then it will look like this. Now we will have glass molecules down here, and then on top of it, we will have water molecules spread all over the glass. So in this case, we say water has wetted the glass. It's a glass surface. So in this case, there's liquid wetting the glass. So in this case, this is water and it has wetted the glass. Wetted the glass. And the reason why it has wetted the glass is because of adhesive force of attraction between the glass molecules and the water molecules. Another example where adhesive force act is paint sticking on walls. Whenever you see those painters painting the walls. The reason why paint stick on walls is because of molecules of two different kind. We have molecules of paint, and then we have molecules of the wall. Now the molecules of the wall are different from the molecules of the paint. Now the paint will stick on this wall because there is a force of attraction between molecules of the paint and the molecules of the wall. That is the force we call adhesive force. Then we have ink sticking on paper. Like right now I'm writing. Let me write here, writing. Now, the reason why this ink sticks on this wall is because of the force of attraction between the ink. Ink, remember, is ink is in liquid state. So the particles or the molecules are in liquid state. And then the paper is solid state. So we have two categories of particles here. We have particles of liquid and particles of solid. So now when you write, there is a force of attraction between the particles of the liquid, that is the ink, to the particles of the solid, that is the paper. And in that case, that's what we call adhesive force, and that force makes ink to stick on the paper. And then another scenario is a chalk mark sticking on the board. Whenever a teacher is writing on the board using a chalk, we have two particles. We have particles of a chalk molecules, and then we have the board molecules. Now, when the chalk molecules interact with the board molecules, these are molecules of different kind, then adhesive force will take part, in which they will attract each other. That's why you can see the writings on the wall. So adhesive force is a force of attraction which only takes place when the molecules involved are of different kind, like ink and paper, wall and paint, chalk and board, and then water and glass. Now this has led us to the second category of force, which we call cohesive force. Cohesive force refers to the force of attraction between molecules of the same kind. Remember, this is different from adhesive force because we said in adhesive force, we have force of attraction between molecules of different kind. But now in cohesive, we have molecules of same kind. And you can use this formula for adhesive force. We have D in adhesive, and then we have D in different kind. And then if you know adhesive force, then you will know automatically cohesive will be molecules of the same kind. So for cohesive force to exist, the particles or the molecules involved must be of the same kind. A good example in this case is a water molecule. Now, when you have a water molecule, like it's spherical in shape, water molecule or a water drop is spherical in shape, then inside this water drop we have water molecules. Remember, molecules are very small, so if you see a drop of water, it means it is composed of millions of molecules. Now between these molecules there is a force between them, the force of attraction between these molecules, and this force of attraction is the one that now we are referring to as a cohesive force. You can see this force is acting between molecules which look alike, all molecules of the same substance, that is water. So that's what we call cohesive force, and this force is the one which makes a water drop to appear spherical. Like for example, I am very sure if you have ever opened and closed a tap, the last drop from a water tap, it looks like it is spherical. Or if you put a liquid in a burette, water in a burette, and then you open the tap and then the liquid is moving out as drops, you will see that drop as if it is spherical before it falls on the ground. So the force that makes that water drop to appear spherical is the force which we call cohesive force. The molecules between that water drop are attracting each other. So in that case, we call it cohesive force, and then you should differentiate it from adhesive force, because adhesive force is force of attraction between molecules of different kind. Like in this case, if you have a paint and a wall, that is adhesive force, because paint has different molecules, a wall has different molecules. But for cohesive, is molecules of the same kind, like water and water. So we have some of the effects of cohesive and adhesive force, and as you can see, these two forces are almost similar. The only difference is adhesive is between molecules of different kind, and then cohesive is molecules of the same kind. Now, when you have a scenario like capillary tubes water, dipped in water, and capillary tubes dipped in mercury, these are two liquids, and these two have different molecules. And then capillary tubes also have their own molecules because they are glass. But I'm talking about the liquids and how they be when you dip capillary tubes, what happens. For water, its density we said is 1000 kgs per cubic meter. Then for mercury, its density is 13,600 kgs per cubic meter. So the behavior of cohesive and adhesive force will depend on the density of the liquid. So if the liquid is low dense, it has a low density, then it means here adhesive, if you interact it with another substance, adhesive will be high than cohesive. Then if you have a liquid with high density, it will mean cohesive will be high than adhesive. If you take mercury and interact it with molecules of another type, then cohesive, the force of attraction between molecules will be stronger than the force of attraction between mercury and another substance. But if you take a liquid which is less dense, like in this case water, it means the force of attraction between water and the other substance will be higher than the force of attraction between the water molecules. Like in this case, if you have capillary tubes dipped in water, we have two different types of molecules here. We have water molecules, and then we have glass molecules. Now, in this case, water is less dense, and then as we have mentioned, it means adhesive force will be stronger. So if adhesive force is stronger, we expect the point where the liquid or the water meets the glass, the liquid will try to climb through the glass. So in that case, it means here adhesive force is stronger, adhesive is strong, and then cohesive is weak. So like in this case, we are saying in both capillary tubes, water curves upwards. Like in this case, if I can draw a good example of that capillary tube now, when it's wide, where you can see in both cases, water curves upwards like this. It forms a curve like this. This means the force between the water molecules was weak and the force between glass and water molecules was strong. That's why the liquid tried to climb up through the glass, because the force between the wall of the capillary tube and the water is very strong. That is, adhesive force is very strong. Now, the type of all the curve which is formed, we call it a meniscus. Look at this. We call it a meniscus, and a meniscus which curves upwards is called concave meniscus. We are going to see how different is it when it curves downwards. So the second scenario that we have is when you dip capillary tubes in mercury, and as we said, when a liquid is of high density like mercury, density high, it means the force of attraction between molecules of the same kind, that is cohesive force will be high. Then adhesive force automatically will be low. Whenever we have high cohesive force, it means adhesive force is weak. And this means now, in this case, if you dip the capillary tubes the liquid will want to stay with itself. That's why you can see at this edge here, the liquid does not want to crimp or to be close to the walls of the glass. So it means in this case, adhesive force is weak. But now, if you look at the liquid itself, the liquid even forms a meniscus upward. The liquid wants to bind itself together. So it means here cohesive is high. And you can know if cohesive and adhesive is high depending on the density of the liquid. If the liquid is high dense, it means cohesive force of attraction between molecules of the same kind is higher than the adhesive force, which is the force of attraction between molecules of different kind. Now, the other thing that you should note is that in both capillary tubes, the liquid is below the liquid in the glass. So it means it does not want to wet the glass, and it's even lowest when the glass has a small radius. Another thing that you should note is that it forms a convex meniscus, or it bends a downward. In this case, if I can draw a bigger diagram, if the capillary tube is like this, then the liquid, now mercury in this case, bends like that. This means at this edge here, the liquid does not want to interact with the glass particles. So it means adhesive force, adhesive is weak. But at the middle here, the liquid wants to stay together. Then in this case, it means cohesive is higher. So the reason why this meniscus is formed is because of higher cohesive force than adhesive force. And now a meniscus which is formed like this, or which curves upward, we call it a convex meniscus. A convex meniscus is a meniscus which is formed when a liquid has higher cohesive force than adhesive force and it bends upwards. Now, another scenario where you can compare adhesive and cohesive force is when you have water on a clean surface and water in a waxed surface. Waxed surface, it means it's a surface which was clean and then we applied oil. Now, for water in a clean surface or on a clean surface, if we have a clean surface like this one, let's say this is the glass, and then you introduce your molecule of water. This one is clean. Then you introduce your molecule of water as a drop from up here. When it reaches the surface, the water will spread. The water will spread just as we saw earlier, and this is because the molecules of water will be attracted to the molecules of glass. So in this case, the water will wet the glass. And the reason why water wets the glass is because adhesive force between the glass and water molecules is stronger than the cohesive force between the water molecules. So the cohesive force which was existing between these water molecules will be weak when it interacts with the adhesive force because water has low density. Now, when we have water on a waxed surface, it means the surface now, if it was a glass like this one, we bring oil and smear on this surface such that it will prevent the direct contact between water and the glass molecule. So this one is waxed. On a waxed surface now, when you drop your water drops from up there, when they reach the surface, there will be no contact between a glass and the water molecules. So the water molecules will remain in spherical form because they are not in direct contact because of a layer of oil, or which we call a waxed surface. So in this case now, the water will not wet the glass. No wetting the glass. So in this case, cohesive force is strong than the adhesive force. And the reason why cohesive is stronger than adhesive is because the contact between the two molecules of different kind is small because of the smeared oil, and then the contact the force of attraction between the molecules of water is strong because